Hello. In this video we're going to graph f of x equals 3x squared minus 3x minus 6 all over x squared plus 8x plus 16. Before we do anything, I actually want to factor everything here. This function can actually factor. If you look at the numerator, there's a common factor of 3. So we have 3 times, and what's left is x squared minus x minus 2. And the denominator actually will factor as well. This is a perfect square trinomial, which is x plus 4 squared as a factorization. The numerator factors just one more time, so this is actually 3 times x plus 1, x minus 2, all over x plus 4 squared. Fantastic. Notice that there are no common factors, so nothing actually simplifies. And it's important to understand this because actually if something did cancel from the denominator to the numerator, it's possible to have what's called a hole in the graph. But because there isn't any common factor, we don't have to worry about that. So let's start out with finding the vertical asymptote. Now the vertical asymptote comes from the denominator, and we set it equal to 0. I could set the entire thing equal to 0 and solve, but it's just the x plus 4 that needs to be 0. Subtract 4 means that x equals negative 4. But realize that this is actually multiplicity 2. It's an even multiplicity. Now let's look at the horizontal asymptote. The horizontal asymptote actually comes from the degrees of the problem. The degree of the numerator is 2, the degree of the denominator is 2. They're the same thing. Because they're the same, we look at the ratio of the leading coefficients. So that's going to give me y equals 3 divided by 1. And simplified, that gives me y equals 3. Now let's look at any x-intercepts. And the x-intercepts come from the numerator. That's 3 times x plus 1 times x minus 2. And I'm going to set that equal to 0. Now 3 is never equal to 0, so that doesn't really do anything. But the x plus 1 sometimes is equal to 0 when x equals negative 1. And x minus 2 is a 0 when x equals 2. So we actually have two x-intercepts, negative 1, 0, and 2, 0. So we have those two. And we also have a y-intercept because the vertical asymptote is x equals negative 4. Plug in 0 for x, that goes away, that goes away, that goes away, that goes away. The only thing you're left with is negative 6 divided by 16. And simplified is negative 3/8. Fantastic. The only other thing we need is to answer, does it cross y equals whatever our horizontal asymptote was, which is 3. Well, again, we set the numerator, and I'm going to go back to the original problem here. Not the numerator. We set the entire function, 3x squared minus 3x minus 6, all over x squared plus 8x plus 16 equal to 3. And solving this gives me 3x squared minus 3x minus 6 is equal to 3x squared plus 24x plus 48. Now I got all these numbers over here by multiplying both sides by the x squared plus 8x plus 16. So I just distributed the 3 to all three of these terms, and that's what we get. Notice that the 3x squareds cancel each other. And I can get the x's on one side. I'm going to go ahead and add 3x to both sides here. So that means I need to subtract 48. So that goes away, that goes away. So I'm left with negative 54 is equal to 27x. And divide by 27 means x equals negative 2. So the answer is yes, it does. And it crosses at negative 2. So the coordinate where it crosses is at negative 2, 3. Fantastic. Let's graph everything we know now. our vertical asymptote is x equals -4. So 1, 2, 3, 4. There we go. Our horizontal asymptote is y equals 3. 1, 2, 3, and do a horizontal line here. Fantastic. That's y equals 3. Good. Next, plot the intercepts. -1, 0, and 2, 0. Then plot the y-intercept, 0, -3/8. And that's going to be something about right there. Notice, however, that it also crosses the horizontal asymptote at -2, 3. So at -2, +3. So at that point is where it crosses. And that's good because these all must connect, and the multiplicities for the zeros was 1, which means it must cross there. So it has to cross and go up towards that point. And this is going to cross and go back up towards the horizontal asymptote. Now, at this point, it's -2, 3, but it got there from a multiplicity of 1, so it has to cross, which means it's going to keep going up towards the vertical asymptote this way. Here's the thing, though. It doesn't flip to the other side. And the reason it doesn't flip to the other side is because if you look at the vertical asymptote, its multiplicity was 2. It was an even multiplicity. And because it's an even multiplicity, it stays on the same side. So it's going to look something like this. And one thing is sometimes nice to graph this. So if you go to your calculator, I would do alpha y equals enter, if you can, and then do 3x squared minus 3x minus 6, and then go down to x squared plus 8x plus 16. All I've done is I've typed in the function. Then graph it. There you go. Now this actually does kind of help that we did do the function right. And you can kind of see that the function's still over here. But to see that a little bit better, I'm going to make this go to -20 for the x value, and for the y maximum, let's do, shall we say, +20. And then see. There we go. Fantastic. That is the way that it looks. Alrighty, well, we'll see you in the next video. Have fun.